we should create log file. To create it, we click on force icon below data section and save it anywhere. The only thing you should pay attention to choose the log format on a file. Afterwards, we have to observe our data. With this task, the command browse will help us. And this command shows us all the data. In our case, data is time series, numerical, continuous. Here we can see that one of our variables is rider. This means that data didn't accept this data. To fix it, we need to run following command. The string variable name, in our case it's here, gp, comma, replace. If you haven't done any grammatical mistakes, it should say that all characters are numeric replaced as int. So after this, as we choose time series data in order to observe the dynamics in economics for the period of time. However, Stata didn't recognize that the variable labeled as year is a time series variable. In order to say to Stata that this is a time interval, we should run another command, which sounds like tset and variable name. So now Stata understands that this is a timeline. Next command help us to somehow connect and integrate MS Word in Stata. Let's write ssc install sdoc. After completing this command, Stata gives us opportunity to save our statistic materials as a doc file and make sure if you have internet connection beforehand in order to avoid interruptions, as this command needs internet access. Then we should give a summarize by command sdoc sum. After completing this command, Stata gives us opportunity to see summary in a Word format. We should open it by clicking my file. Actually, I've already opened this file. It will look like this. You should copy it out and paste it in your research work like this. So let's start making analysis. So first command is two-way TS line. Let's start from GDP. We use this command to observe the dynamics, which gives us information about positiveness or negativeness of changes. And you can see that for last 50 years, the GDP of Germany was going up. In order to observe the correlation between two of our variables, which will help us to figure out the impact of our variables on each other, we need another command called the two-way scatter and variable names lfit. So as you can mention, there is a line which shows us a common tendency of correlation. This line is making due to lfit command, and this peak also will be on our file. To avoid repeating the same, I'll say that all our statistical analysis will be transferred into our research. You should just copy it out and paste it in your file anywhere. And let's continue our research work. So our next command is histogram. Histogram and name of variable. Let's take a trade, comma, k density norm. K-density norm will help you to show the bell-shaped line, which is an example of normal distribution of data. This command gives us an information about the data distribution. If two lines lies on each other, it means that data is normally distributed, but it's always a rare phenomenon than a norm. As you can see, in our case, it also doesn't match. One more type of statistics is a graph box. Let's take text revenue. Graph box gives us rectangular with some extra lines, each of which explains some facts. For example, inside the rectangular we have 75% of our information, and the horizontal line dividing our information is a median, and two other horizontal lines beyond rectangular are minimum and maximum values. We're getting to the most interesting part. Pearson pairwise correlation will show the correlation between all chosen variables. In order to figure out significance of our relationships, we should write PV core with double R and list of all variables. After you've write down all variables, you should put comma and write star 0.05 and sig. So star 0.05 means that says to Stata that it should put stars on variables which correlation has a significance level 0.05. In our science, we have some hypotheses. In order to accept them, we need more than 95% evidences. However, in order to refuse the H0 hypothesis, which says that all variables are independent, we need only 5% of evidences. And if your p-value is less than 0.05, Zeta will put a star, and it will that your analysis is mathematically proven. So here you can see that GDP and GDP has a 100% correlation, while exports of services and goods with GDP has a 93% of correlation with a significance level of 0.00, which means it's really reliable data. Our next command is analyze the regression. In order to analyze it, we should write reg and all the variables. Linear regression in data platform given with ANOVA table on top left one and model parameters on top right, and result table below the two previous tables. Regarding our model parameters tables, we can see the number of observations, it's 50, and f value gives us information about quantity of variables, in our case it's 7, and the second number gives us information about the rest of years of our data, it's 42. P value gives us information about the level of error, and any result below the 0.05 in our field is considered as a good. R squared is a coefficient indicates how closely the relationship between the regression factors and the dependent variable. How the result is closer to 1, the more pronounced the dependence. In our case, you can see the 0.96, which is really good. Going to results table, t-test is like first column in our table is H0 hypothesis test, which will claim that all variables are independent. If our p-value is lower than 0.05, it means that we discard H0 and go to H1, which states that the variables are dependent. Here you can see that we have 5 values less than 0.05 out of 7. It's a really good result. Final steps, we should write this command as doc alpha and all the variable names. This command show us the reliability of our research. Scale reliability coefficient is lower than 0.05, which is really good. At this moment, we should run ssc install jb. So after this, we should check the StatVIF is command that calculates the variance inflation factors for independent variables in your model. If the mean VIF is lower than 10, it says that there is no multicollinearity. Our next command is predict y hat. If we browse our data, we can see that y hat variable, which is calculates weighted and state-specific linear predictions of the observed variables. Here is it. Last test is a state hit test. This test for heteroscedasticity. In a linear regression model, this command works of the null hypothesis that the variance for each observation is around the same finite value. If a linear regression contains this phenomenon, we are saying that rather than uniform variance, the variance is influenced by one or more variables. So thanks for your attention. This is the end of video about data.